little weird and takes some getting used to. By default, most instance variables are protected. Okay, they're essentially private. Whoever's using your class, they can call your public methods, but they can't access your instance variables. So our calculator brain only has one instance variable, which is its operand, its internal operand, or at least it's going to start out that way with only this one instance variable. Notice it's a double, okay, double precision calculator. And then our method declarations for our class go here in this space after the instance variables and before the @ end. And we're going to have two methods for our model. One is to set the operand, and then the second one is to perform an operation on the operand. And it's actually going to return the updated operand just as a convenience to have fewer methods and to make it kind of simpler. Notice that the set operand method, its return type, the kind of thing it returns, is void. Okay, that means it returns nothing. This is different than just not putting that parentheses there at all. That means something different. That actually means it returns an object. So if you have a method that returns nothing, you need to say parentheses void as the return type. Notice the other one is parentheses double. It returns a double. Okay? This is the name of this method. Set operand colon is what we would say. Some people might say it's called set operand, but usually if it takes an argument, we say the word colon when we're saying the name of it. And I'll show you in a second what happens if it has multiple arguments, because it's kind of funky. Definitely not what you're used to. This is the only argument to this method. It's a double. Okay, it's called an operand. That's just going to be the name of the local variable inside our implementation. Since this is the header file, you could really call that anything you wanted. Again, only one argument in this method. Don't forget to put a semicolon at the end of this. Just like in any other C-based language, semicolon is the end of this line. White space generally doesn't matter in here, although there's some places where it matters, and we'll talk about that later on in the quarter. So this method returns a double. It takes an argument, as an argument, this ns string star, so it actually takes a pointer to an object as its argument. That's what ns string star means, a pointer to an ns string, an object of class ns string. And we'll talk a lot more about how we pass objects around. All objects in Objective-C are allocated on the heap, so you always have pointers to them. There's no way to like allocate them on the stack as a local variable or any of that business. They're all allocated out of the heap. This argument called operation, again, doesn't really matter in our header file. So here I've thrown in a wacky method. This is not part of our calculator brain, but I just wanted to show you what it looks like if you have two arguments. So this method has two arguments, and it would be called foo colon bar colon. That's what people would call this method, foo colon bar colon. Not foo bar, foo colon bar colon, okay? And you know, the first argument, notice that the arguments like zap and pow are interspersed between the names. It's not like Java or C++ where you have the long name of the method and then open parentheses and then all the arguments separated by commas. Okay, the name of the method and the arguments are kind of interspersed. The reason Objective-C does that is because the goal when we write good Objective-C code is we want it to read as close to English as we can. Okay, so we want those argument names, the name of the argument like foo colon, to match up with the thing we're passing in a readability way as we read left to right. And you'll see a lot more of this as we write more and more code, why this makes sense. It's actually kind of nice. This one returns a pointer to an object, an NS array I've just made up here. Okay, so that's a pointer to an NS array. It is possible for these pointers to be nil. Basically, there's a keyword in the language, nil, which means there's no pointer, basically a nil pointer. Dereferencing a nil pointer by sending a message to it does not crash your program. So that takes some getting used to, okay? So it's not like a void pointer. It's a little different than that. Notice this second argument, its type, ID. See that type? That's a new type. That's Objective-C only. That means pointer to any object. So you can pass a pointer to any object. You could pass a string in here, an array, etc. And you might say, whoa, wait a second, that's pretty dangerous, because what if this method thinks that this object is a string and I passed in an array and it's going to crash? And yeah, that's true. Luckily, there are ways in Objective-C to ask an object, what is your class? Or do you respond to this method? So that you can prevent yourself from crashing by asking that question first. And then you're going to see how we can take an ID and put a little bit of extra syntax in there to turn into a protocol, where it's any object that responds to a certain protocol. Okay? So I'm going to take off the foods app. So this is basically the starting public API of our model. I'm going to be adding a couple of instance variables I'll need in my implementation, but that'll be a little later. So now let's look at Calculator Brain's implementation. Yeah, question?
What is the negative sign at the start of the
Oh yeah, so he was asking, each of the methods had this dash at the beginning. That's either a dash or a plus, and I'm going to talk about what that means next week. But basically a dash means it's a message you send to an instance. A plus means it's a message you can send to that class. And that probably doesn't mean a lot to you right now, but next week it'll mean a lot. So for now, it's always a dash. We'll talk about plus next week. So this is calculatorbrain.m. It's the implementation of Calculator Brain. So it's going to have implementations of all those public methods, the two that we declared, and also it's going to have implementation of private methods that are only for us to use. Okay? We obviously have to import our own header file. I forgot to say, you see the @sign implementation, @end. That's similar to @sign interface, @end, except for this is our implementation. Also, notice we didn't put the colon NS object. We don't put our superclass here in the implementation, but we do have to include or import our own header file. And that's so that our implementation knows what our instance variables are and things like that. So this is what it looks like to put method implementation in. Almost exactly the same as the header file, but no semicolon and curly braces instead. Question? Yeah, the question is, do we ever need to use include versus this thing import? If you look at import, it kind of does all that magic includes for you, so that if you include something, it includes something else, and you get these roundabout things. It manages most of that, not all of it, for you. So # import is the way we include header files in Objective-C. We never use include. You would never use it in your code. But it is a strict superset of C, so # include is there, it's just we don't use it. Okay, so back to this. Set operand, no semicolon there, but curly braces instead, and the code goes here. So set operand, for example, its implementation, no semicolon there. Its implementation, very simple, operand equals n operand. Okay, that's going to be the entire implementation of that method, super simple. We have another method. I'm not going to show you the implementation of that method in the slides. I'll show you when we do the demo. But I wanted to show you what it looks like to send a message. So we talked about declaring methods and objects, but what about sending them? And this is what it looks like. There's this kind of funky square bracket notation. Okay? You basically put square brackets at the beginning and at the end of your message send. All right? And the first thing after the square bracket is the object you're going to send the message to. Here I'm sending this message called send_message: to the operation, which is this NS string star. Okay, so it's a string message. So this send message that I'm sending better work on strings, because that's what I'm sending, right? Send message to it. And then this is the argument that I'm passing along with send_message: Okay, so I just wanted to show you that syntax. Obviously, our implementation of perform operation is going to have a lot of different stuff in there. Okay, so that's the model's header file, its interface, and now its implementation. The last thing I'm going to show you is the controller, its header file. We're not going to do its implementation, but we'll show its header file. So a couple things to note here. One is our controller inherits from a class in the iOS SDK called UIViewController. See it there? And that's why I'm importing UIKit.h, which is the UIKit's master header file. The UIKit is a thing that has buttons and sliders and view controllers and views and things like that in it. So I have to import that because it's my superclass. Okay, so note that. UIViewController is how the UIKit plugs into your MVC structure. Right? So MVC is part of how the UIKit expects you to do your work. It's not just a nice idea to make it work. It's actually part of how the UIKit expects you to behave. So this first instance variable, right? This is an instance variable and public header file here. Instance variable is our brain. This is, if you remember our MVC model, this is the pointer over to our model. Okay, and remember that our controller can talk to our model as much as it wants. So that's a green arrow. That's what that pointer is. Then this pointer, the display, as well as these two methods, are the target action thing, the little that we hung up, and also the green arrow that can go from a controller to its view. So the display is that green arrow that goes from the controller's view, and then these two methods down here are actions, the two actions that are being sent. So hopefully it's somewhat self-explanatory how I'm declaring it here. There is something interesting here, this IB action, you see that, an IB outlet. Okay, IB action is the same as void. It's exactly the same. The only difference is the interface builder program looks at your header files so that it knows which things are things that you want to wire up using interface builder. So it's the same as void. It's probably even type-def to void somewhere in some header file. But you put it in there anytime it's an action you're going to want to wire up in interface builder, which we'll see in a moment. Same thing with IB outlet. Okay, that's void as well, but it's an indicator to interface builder that this UI label pointer is going to be something we're going to wire up using this interface builder tool. Now you see what it's going to look like in interface builder in the upper right hand corner there. That's approximately what our user interface is going to look like. And so we're literally going to be dragging connections from our controller to these various buttons and labels and stuff with the mouse in the interface builder. So on this screen is all three things here, the controller, the model, and the view. Okay, and you can hopefully imagine the connections to them. That's what we're going to do today. I want to show interface builder really quickly, just so that when I'm doing this, because when I do it, I'm going to drag it out, and you're going to say, oh, what do you do right there? So I'm going to give you a little preview of what I did right there. The first thing to note is this file right here, which has my user interface mostly built. Okay, this thing is in a file called calculatorviewcontroller.zib. I have the name of the file in the lower left corner right there. You can also see it in the main window of Interface Builder, which is that small window at the bottom. So I told you that the view is like the minions of the controller. That's why we put all the views, including the buttons and subviews, into a file that has the name of our controller.zib. Sometimes that confuses people a little bit, but that's why we do that, because these things are the minions. They essentially are being driven by Calculator View Controller, which is our controller. One other thing to note is this little icon that says Files Owner. Very important to understand what that is. Since this is Calculator View Controller's minions, the Files Owner for this file, this in Interface Builder, is our controller. So anytime we want to wire something up to our controller in either direction, that's the icon we're going to use. Okay, sometimes people get a little bit confused. Where's my controller? I don't see it. It's the Files Owner in this file. All right. Now, let me talk briefly about these four windows here that appear in Interface Builder. These are the only four windows really you're going to see. The one in the left there, Library, that's a big list of all the objects in the UI kit and some other kits that you can drag out to build your user interface with. So you can see right there we've got label and round rect button and a text field. We have a switch, a slider. These are all things that we can just pick up with the mouse and drag them out into our view, our controller's view, to build whatever our user interface is, and we'll be doing that today. On the right, that window is called the inspector, and that, if you select any object in Interface Builder, it's just an inspector that lets you set all kinds of attributes of it. The contents of it change as you select different things. Obviously, the contents are different if it's a button selected versus a UI label or something else. And then the window on the bottom, that's the main window. That has a graphical representation of kind of top-level views, but also objects that don't have a visual representation, like your controller, Files Owner, right? They need an icon so you can drag lines between them. That's where they live. You can view it in different ways. This one right here is in a big icon mode, but you can list it kind of a list mode, and then there's like a browser type mode, like the Finder in the Mac, to find your objects. And when you have a big user interface that has a lot of stuff in there, it can be sometimes convenient to go find things in there versus trying to click around in them. Up in the middle window, top middle, and the top middle is our view. So we directly